In this video, I will discuss about decimation in frequency fast Fourier transform algorithm, that is DIF-FFT algorithm. Here in DIF-FFT algorithm, we are supposed to do the decimation in 3 stages. This is the first stage decimation, which is 8-point DFT. Second stage decimation is 2 4-point DFTs, and in third stage decimation there are 4 2-point DFTs. Let me explain in detail. We know that the n-point DFT expression is given by x of k is equal to summation n varies from 0 to n minus 1 x of n wn power nk. So here wn is known as twiddle factor, that is wn is twiddle factor, which is represented as e power minus j 2 pi by n. I will call this as equation 1. Now I will represent equation 1 by splitting this summation into 2 parts, that is x of k is equal to, as here the summation is varies from 0 to n minus 1, I will split into 0 to n by 2 minus 1 and n by 2 to n minus 1, that is summation n is equal to 0 to n by 2 minus 1 x of n wn power nk plus, so it should begin from the next value, that is n by 2, that is n is equal to n by 2 to n minus 1 x of n wn power nk. So this expression is same as, so now I will rewrite this expression as x of k is equal to, I will write the first summation as it is, that is 0 to n by 2 minus 1 x of n wn power nk plus summation, here also I will make the summation as 0 to n by 2 minus 1, that is say n is equal to 0 to n by 2 minus 1 x of, I supposed to write it as n plus n by 2 wn power, here it is n should be replaced by n plus n by 2, that is k n plus n by 2. So this summation is same as this one. Further I will simplify this as x of k is equal to, I will write the first part as it is 0 to n by 2 minus 1 x of n wn power nk plus summation n is equal to 0 to n by 2 minus 1 x of n plus n by 2, here I will write it as wn power k into n, I will split it wn power k n by 2, which is same as this one. Or I will rewrite this expression as, I will take, as this is constant, I will take this out of the summation. I can represent it as x of k is equal to summation n is equal to 0 to n by 2 minus 1 x of n wn power nk plus, we have wn power k n by 2, wn power k n by 2 summation n is equal to 0 to n by 2 minus 1 x of n plus n by 2 wn power n into k. So now here I will take this part, that is this, I will write here, say wn power k n by 2 is equal to, we know that wn is nothing but e power minus j 2 pi by n. So e power minus j 2 pi by n into, we have the remaining term, that is k n by 2, k into n by 2, or I can represent it as n will get cancelled and 2 will get cancelled, will get e power minus j pi into k, or I can represent it as e power minus j pi into k, and we know that e power minus j pi is nothing but cos pi minus j sin pi raised to k. We know that cos pi is minus 1 and this term will be 0, that is minus 1 power k. So now I will try to replace wn power kn by 2 by minus 1 power k. So therefore I can rewrite this expression as x of k is equal to summation n is equal to 0 to n by 2 minus 1 x of n wn power n k plus I will replace this with minus 1 power k. Write the remaining part as it is. N is equal to 0 to n by 2 minus 1 x of n plus n by 2 wn power nk. Or I can further simplify this as x of k is equal to summation n is equal to 0 to n by 2 minus 1. Here I will take it as x of n plus minus 1 power k x of n plus n by 2, because here this term is common, I will take it as common, wn power nk. I will call it as equation 2. So now split this x of k into even and odd numbered samples. So as we know, in decimation in time, that is DIF-FFT algorithm, we have splitted x of n into odd and even numbered samples. So in decimation in frequency, we have to split x of k into even and odd numbered samples. So now so to split x of k into even numbered samples, we have to take x of 2k, that is x of 2k. Here we can see if we take k equal to 0, it will be x of 0. If you take k equal to 1, it will be x of 2. If you take k equal to 2, it will be x of 4 and so on. So we'll get only even numbered samples. So I will take it as x of 2k. That is k should be replaced by 2k in this expression, is equal to summation n is equal to 0 to n by 2 minus 1. We have x of n plus minus 1 power 2k x of n plus n by 2 wn power n is written as it is, k is replaced by 2k, that is 2nk. And here k varies from 0, 1 up to n minus 1, that is n by 2 minus 1. Now I will split into odd numbered. To get odd numbered, we have to add 1 to this. So we are supposed to take it as x of 2k plus 1. That is x of 2k plus 1 is equal to summation n is equal to 0 to n by 2 minus 1. We have x of n, that term is written as it is, x of n plus minus 1 power. So here 2k plus 1. 2k plus 1 x of n plus n by 2. We have wn power n 2k plus 1. K varies from 0 to n by 2 minus 1. So here I will call this as equation 3 and I will call this as equation 4. So now from equation 3 I will take this part, that is if I consider wn power 2nk, so this can be written as wn square n into k or I can write it as Wn square can be written as Wn by 2 into Nk, or it is also equal to Wn by 2 power Nk. So therefore, so also here we can see that minus 1 power 2k, that is minus 1 power 2k. So for any values of k, its value is always equal to 1. For example, if you take k equal to 0, the value is 1. When you take k equal to 1, it will be plus 1. So minus 1 power 2k, for any values of k, its value is always 1. Now let me rewrite equation number 3 as, equation 3 can be written as, that is x of 2k is equal to summation n is equal to 0 to n by 2 minus 1 x of n. So here this value is 1, that is plus, we have x of n plus n by 2, and the value of this is nothing but w n by 2 power nk. So here also k varies from 0 to n minus 1. K varies from 0 to n by 2 minus 1. I will call it as equation 5. From equation 4, that is this equation, from equation 4 we can see that the value of this, that is wn power n 2k plus 1 is equal to wn power 2nk into wn power n. So this is also written as wn power 2nk is nothing but wn by 2 power nk into wn power n. And also this term, that is minus 1 power 2k plus 1 is equal to minus 1 power 2k into minus 1 power 1. So its value is always equal to minus 1. So now I can represent equation 4 as, therefore equation 4 can be written as, now let me rewrite equation number 4, that is x of 2k plus 1 is equal to summation n is equal to 0 to n by 2 minus 1. We have x of n minus, because this value is minus 1, x of n plus n by 2, and this term is nothing but, I will write it as wn power n into wn by 2 power nk. Let me write it like this. So I will call this as equation number 6. Here also k varies from 0 to n by 2 minus 1. So here equation 5 and 6 gives DIF-FFT of x of k, because we have splitted x of k into even and odd parts. So these two equations gives the DIF-FFT of x of k. So now let me take this term, that is this term, as f1 of n. Let f1 of n is equal to x of n plus x of n plus n by 2, and let me take this. So here let me take this term, this entire term as f2 of n, that is f2 of n is equal to x of n minus x of n plus n by 2. We have wn power n. So here f1 of n and f2 of n are two n by 2 point sequences. That is here f1 of n and f2 of n are two n by 2 point sequences. Now I will write equation number 5 as, therefore equation 5 and 6 can be written as that is x of 2k is equal to x of 2k is equal to summation n is equal to 0 to n by 2 minus 1. We have f1 of n into, here we can see that wn by 2 power nk, wn by 2 power nk. So here k is equal to 0, 1 up to n by 2 minus 1. Similarly, x of 2k plus 1 is equal to summation n is equal to 0 to n by 2 minus 1. We have f2 of n. So here also this entire term is f2 of n into wn by 2 power nk. Here also k varies from 0, 1 up to n by 2 minus 1. So let me call this as equation number 7 and this as equation number 8. So here we can observe that x of k is n point DFT, x of 2k and x of 2k plus 1 are 2 n by 2 point DFTs. So here we have done the decimation in frequency. So the name is decimation in frequency FFT algorithm. So this is the result of first stage decimation, that is here in this block diagram. The formula for f1, this part is f1 of n and this part is f2 of n. That is first decimation is done. So here if we consider let n is equal to 8 to 8, let me write the output of first decimation stage, that is f1 of n. We know that f1 of n is equal to x of n plus x of n plus n by 2, x of n plus x of n plus n by 2. So if we take n equal to 0, it will be f1 of 0 is equal to x of 0 plus x of n by 2, that is x, n is 4, n is 8, it is x of 4. For n equal to 1, it will be x of 1 plus x of n is 1, 4 plus 1 is 5. For n is equal to 2 is equal to, so here n varies from 0 to n by 2 minus 1 because it is n by 2 point DFT. So let me write here, in both the cases n varies from 0 to n by 2 minus 1. It means if we take n is equal to 8, so it varies from, n varies from 0 to 3. That's why f1 of 2, that is n equal to 2, it will be x of 2 plus x of 2 plus 4, that is 6. And f1 of 3 is equal to, we have x of 3 plus x of 3 plus 4, that is 7. So these are the output expressions of the first stage decimation. Similarly, we know that f2 of n is equal to, we have x of n minus x of n plus n by 2, x of n plus, sorry, minus x of n plus n by 2. We have another factor, that is wn power n. So here also n varies from 0 to n by 2.1, that is 0 to 3. So for n is equal to 0, f2 of 0 is equal to, we have x of 0 minus x of 4, here w8 power 0. For n is equal to 1, f2 of 1 is equal to x of 1 minus x of 5. We have w8 power 1. f2 of 2 is equal to, we have x of 2 minus x of 6, w8 power 2, and f2 of 3 will be equal to x of 3, that is minus x of 7, w8 power 3. So these are the outputs of first decimation. So these are first decimation stage outputs. This is the block diagram. Now let me draw the signal flow graph after first stage decimation. This is first stage decimation which is already done. So we got the output f1 of n and f2 of n. Now let me draw the signal flow graph after first stage decimation. In first stage decimation, x of n are the input sequences, f1 of n and f2 of n are the output sequences. Let me draw. So here there was the 8-point DFT block. Now I will replace that with a signal flow graph. So here we can see that f1 of 0 is equal to x of 0 plus x of 4. So here the output is f1 of 0. The input is x of 0. We are supposed to give the arrow mark like this. This is x of 0. It should be connected with x of 4 because f1 of 0 is equal to sum of x of 0 and x of 4. X of 0 plus x of 4. So here we have x of 4. So just connect the line from x of 4 to this line. So here x of 4 is connected. We have to show the arrow mark like this. So this is f1 of 0 which is equal to x of 0 plus x of 4. This is the point where both the signals will added up. f1 of 1 is x of 1 plus x of 5. So here x of 1 and x of 5. So this is the signal. So f1 of 1 is x of 1, x of 5. Similarly, f1 of 2 is x of 2 and x of 6. Similarly, f1 of 3 is x of 3 and x of 7. So here f2 of 0 is x of 0 minus x of 4. This result should be multiplied with w8 power 0, that is twiddle factor. So here f2 of 0 is x of 0 minus x of 4. So just here we have x of 4. We have to connect x of 0 line with this line. So it will be like this. So show the arrow mark like this. This arrow mark indicates the direction of flow of signal. So here we supposed to write it as minus 1 because it is x of 0 minus x of 4. We have written minus 1 on x of 4 line. It means it is minus x of 4. So here we supposed to write w8 power 0, that is twiddle factor value. Similarly, f2 of 1 is x of 1 minus x of 5. It should be like this. So here it is minus 1 and here the twiddle factor value is w8 power 1. Similarly, f2 of 2 is x of 2 minus x of 6, that is minus 1. It indicates minus x of 6. Here the twiddle factor value is w8 power 2. Then we have x of 3. You show the arrow mark like this. Here it is minus 1 and here the twiddle factor value is w8 power 3. So this is the signal flow graph after first stage decimation. Now we'll try to decimate the second stage, which consists of two 4-point DFTs. That is, now in the second stage decimation, the 4-point sequence, that is f1 of n, is splitted into two-point sequences, that is a of 0, a of 1, b of 0, b of 1. Similarly, the 4-point sequence f2 of n is splitted into two-point sequences, that is c of 0, c of 1, and d of 0, d of 1. Now let me write these equations directly. So as here we can see, f1 of 0 is sum of x of 0 and x of 4. So here a of 0 will be f1 of 0 plus f1 of 2, and a of 1 will be f1 of 1 plus f1 of 3. Now let me write a of 0, that is a of 0 is equal to f1 of 0 plus f1 of 2. Similarly, a of 1 is f1 of 1 plus f1 of 3. And similarly, b of 0, b of 1 can be written as b of 0 will be sum of f1 of 0 minus f1 of 2 multiplied with the twiddle factor, that is w4 power 0, because here 4-point DFT. Therefore, I can represent it as b of 0 is equal to f1 of 0 minus f1 of 2, the whole thing is multiplied with twiddle factor w80. Similarly, b of twiddle factor value is w4 power 0, because it is n by 2-point DFT. We have considered n equal to 8, so it is 8 by 2, that is 4-point DFT, w4 power 0. So which is also equal to w8 power 0, that is w4 power 0 is also equal to w8 power 0. Similarly, b of 1 will be, we have f1 of 1 minus f1 of 3, it is w4 power 1. So w4 power 1 is also equal to w8 power 2. So these are the outputs of first 4-point DFT stage. Now we'll consider the second 4-point DFT stage outputs. Here the outputs are c of 0, c of 1, d of 0, and d of 1. c of 0 will be equal to f2 of 0 plus f2 of 2. Similarly, c of 1 is f2 of 1 plus f2 of 3. Similarly, d of 0 is f2 of 0 and f2 of 2, and d of 1 is f2 of 1 and f2 of 3. Now let me write c of 0 and c of 1. C of 0 is equal to, we have f2 of 0 plus f2 of 2, and c of 1 is f2 of 1 plus f2 of 3. It is same as this one. Similarly, d of 0 is, just replace plus by minus, f2 of 0 minus f2 of 2, the twiddle factor value multiplied is w4 power 0 or w8 power 0, both are fine. D of 1 is equal to, we have f2 of 1 minus f2 of 3, the twiddle factor value is w4 power 1 or w8 power 2. So now with the help of these equations, let me replace these two 4-point DFTs with a signal flow graph like this. So this is the signal flow graph after second stage, that is A of 0 is f1 of 0 plus f1 of 2. So A of 0 is f1 of 0 plus f1 of 2, that signal will be added here. Similarly, A of 1 is f1 of 1 and f1 of 3. B of 0 is f1 of 0 and f1 of 2. It should be minus here because in expression we have B of 0 is minus multiplied with w4 0. So here we have to write the twiddle factor, that is w4 power 0, which is same as w8 0. Similarly, B of 1 is f1 of 1 minus f1 of 3, and the twiddle factor value is w4 1, or it is also equal to w8 power 2. So similarly, C of 0 is f2 of 0 and f2 of 2, and C of 1 is f2 of 1, f2 of 3. D of 0 is f2 of 0 and minus f2 of 2. Here the twiddle factor value is w8 0, that is same, and here it is minus 1. The twiddle factor value is w8 2. So this is the signal flow graph after second stage. Now here we can find 4 2-point DFTs. Each 2-point DFT has 2 inputs and 2 outputs. So here it is directly connected. So x of 0 is A of 0 and A of plus A of 1. X of 4 is A of 0 minus A of 1. Similarly, x of 2 is B of 0 plus B of 1, and x of 6 is B of 0 minus B of 1. Now let me draw the complete signal flow graph. This is the signal flow graph after third stage decimation. So here x of 0 is equal to A of 0 plus A of 1. So the arrow mark should be like this. And x of 4 is A of 0 minus A of 1. And here the twiddle factor value is, it is either w2 power 0 or w8 power 0. Here also x of 2 is, it will be like this, and here it is minus 1. Twiddle factor value is w8 0. It is minus 1, w8 0. Here it is like this, and the twiddle factor value is w8 0. Here we can observe that in DIF-FFT algorithm, the input sequence is in order, that is 0, 1, 2, 3, 4, 5, 6, 7 are in order, but the output sequence is not in order. When we compare with the input sequence, the output sequence is in bit reversal format. The bit reversal format means, here we can see that the 0 can be represented in 3 bits as 0, 0, 0. If we read this one from right to left in reverse way, it will be 0 only. So x of 0 can be represented as capital X of 0. Similarly, 1 is represented binary as 0, 0, 1. In reverse, it will become 1, 0, 0. So 1, 0, 0 is equivalent to 4. So here I have written 4. Similarly, 2 is same as 2, and 3 is nothing but 0, 1, 1. In reverse way it is 1, 1, 0, that is 6. Similarly, 4 will become 1, 5 will become 5 only, 6 will become 3, 7 will become 7. So outputs are in bit reversal. Output sequence is in order, whereas output sequence is in bit reversal order. So this is the complete signal flow graph of DIF-FFT algorithm considering n is equal to 8. Now let me write the summary of all the equations so that we can easily understand. So this is the complete signal flow graph of decimation in frequency fast Fourier algorithm for n equal to 8, and these are the outputs. So this column, that is output after first stage of decimation, these are the outputs after first decimation, these all are the outputs after second decimation, and this is output after third decimation, that is DFT. Thus this is the final output, that is nothing but DFT of the input sequence. Thank you for watching.